Today we're talking about circles, which is the beginning of our conics unit. So if we start out with this first circle, we notice that it is centered at the origin, and it has a point B. From A to B is the radius of the circle. So this particular circle has a radius of length r, and if you notice that we have a right triangle here, we know by the Pythagorean theorem that x squared plus y squared has to equal r squared. So that is the very basic form, the general form of a circle centered at a radius, centered at the origin with a radius of r. And we can make an infinite number of right triangles from any of the points that are around on this circle. So let's see what happens when we move things around. When we go to this interactive activity, we see that now, instead of having a center at the origin, my center is now the ordered pair 1, 2. And for any point xy on this circle, we can move that point anywhere we'd like. Try and refresh that real quick. We can move that point anywhere we like, and that will impact the radius and will also impact the ordered pair xy. But notice that if we want to know how far this horizontal distance is between A and C, we would need to take whatever x coordinate this is. It happens to be 7, 7. So let's pick pick something that's not exactly the same. 7, 6, the ordered pair 7, 6. So we'll take the x minus the x, so 7 minus 1 gets me 6 to find my horizontal distance from the center to a perpendicular. And my y value is y minus 2, 6 minus 2, which gets me 4, which is that vertical leg. And so we're going to have an r squared, in this case, that happens to be 36 plus 16, or 52. So what do you notice about finding the value, this horizontal value, when you look at the point 1, 2 and compare it to the x minus 1? Or the point 1, 2 compared to the y minus 2. Well, hopefully you notice that the x minus the x coordinate helps us get our horizontal movement. The y minus the y coordinate helps us to get our vertical movement. And that will be true no matter where we place that center. Y minus a minus 1 and x minus 1 help us get the 7 and the 6 for the vertical and the horizontal movements, and our r squared is always going to be the sum of the squares of the legs. So when we have a circle with a center at 3, 2, and a radius of 1, 2, 3, 4, the equation for this circle is going to be x something squared plus y something squared is equal to my radius squared. My radius is 4, 4 squared is 16. What did we learn from the previous exploration? Well, it has to be x minus 3, because we want to know how far are we between 7 and 3 to get that value of 4, or whatever this coordinate happens to be. Maybe we're choosing, there aren't any nice ones to choose, but for this point xy, we're looking for the x minus the 3 and the y minus the 6. Sorry, the 2. So the equation of this is x minus 3 quantity squared plus y minus 2 quantity squared equals the radius squared, or 16. H is the horizontal movement of our circle. K is the vertical movement of our circle. So x minus the horizontal movement quantity squared plus y minus the vertical movement quantity squared is equal to the radius squared. So here we have another GeoGebra activity. And this further emphasizes the fact that as we move our change our h, we move it to the right, the equation changes by changing the horizontal movement, it's the opposite sign of whatever movement we've made. So shifting it to the left, 8 units from the origin is going to add 8 to the x. Shifting it to the right, 1 unit from the origin is going to subtract 1. Going up 3 units from the origin will change our value for k to be a -3, and going down 5 units, we'll get a y plus 5 squared. And of course, if we change the radius, that's going to change the value of r squared. So, if we have a circle centered at 2, -1 with a radius of 6, and we are asked to find the equation in standard form, we have to take an x minus the horizontal movement squared plus a y minus the vertical movement squared is equal to our radius squared. So radius squared is 36, the x is -2, and the y is a minus 1, and there's our equation of our circle centered at 2, -1 with a radius of 6. When we want a circle centered at 3, -4, passing through the point 6, -12, we want to write that equation in its standard form. That means we're going to start in the same manner. We know that the center is at 3, -4. That's our HK. So x minus 3 squared plus y minus a -4 squared is going to be equal to our r squared. And this is where students realize, oh, I need to find out how long it is from the point 3, -4, the center, to the point 6, -12, so to find the radius of this circle, I need to find the distance between these 2 points. Quite often I hear a groan, oh, the distance formula, that's hard. And I say, wait a minute, it's not hard, it's right there. And students look and they say, what do you mean it's right there? Well, isn't the distance equal to a big giant square root of x2 minus x1 squared plus y sub 2 minus y sub 1 squared? These look pretty familiar, don't they? Here's my x2, here's my y sub 2. Can't I simply say 6 minus the 3 squared plus -12 minus the -4 squared will be equal to my r squared? Get rid of the square root and simply say this is our distance squared or our radius squared. So 6 minus 3 is 3. 3 squared is 9. -12 plus 4 is a -8. When we square a -8, we're taking it times itself, so it will be a positive 64. And 64 plus 9 is going to be a total of 73. If 73 equals r squared, we don't have to take the time to take the square root because we need an r squared over here anyway. Next, we need to find the center and the radius of x squared plus y squared minus 8x plus 4y equals a -11. Well, that's really simple when it's in standard form. We can see the circle, the center, and the radius, but if it's not in standard form, we have to put it there or change it so that it is in standard form. So to do that, we need to complete the square. We need a binomial squared plus another binomial squared is equal to our r squared. So let's gather the x's together, the terms with x, and let's gather the terms with y's together. And then we ask ourselves, how are we going to complete this square? What are we going to add to it in order to make this a perfect square trinomial? Well, if we are working with an x squared tile, and we have 8 of these negative x tiles, 4 of them are going to the right and 4 of them are going down. And so in this little area here, we're going to fill it up with 4 by 4, or 16. So half of 8 is 4. 4 squared is 16. If I add 16 to the left side of my equation, I need to balance it by adding 16 to the right side. We also have a y squared plus a 4y. So if I had a y squared tile, and I want to split the 4y evenly, 2 of these y's are coming over here, and 2 of them are coming down here. So when we have a 2 by 2, we'll get 4 small tiles that we're adding to it. And again, to balance the equation, if we add 4 to the left, we need to add 4 to the right. Now we have a perfect square trinomial. The square root of the first, sine of the middle, square root of the last is how it factors. Square root of the first, sine of the middle, square root of the last. And when we add a negative 11 plus a 16, we get 5, and 5 plus 4 is 9. Our center of our circle is the ordered pair 4, negative 2, and our radius is 3. One more. Let's find the center and radius of an x squared plus y squared plus 10x plus 2y equals 22. So once again, add your x's, x terms, add your y terms, leave some space to ask yourself, what are we going to be adding? But the first step of this is always going to be to subtract the 22, isolate the constant to the other side of the equation. So what is half of the 10, the middle term? Half of 10x is going to be 5x. We're going to use 5x on the right, 5x down below. 5 squared is 25. If I add 25 to the left, I add 25 to the right to balance the equation. Half of 2 is 1, 1 squared is 1. Adding 1 to the left means add 1 to the right. And now we're ready to write our binomial squared. Square root of the first, sine of the middle, square root of the last. Square root of the first, sine of the middle, square root of the last. And then a negative 22 and a positive 25 gets me a positive 3. 3 plus 1 is 4. Center, negative 5, negative 1, radius 2.